Let's solve an application problem involving a hyperbolic function. We are given a function that represents the shape of a power line between two poles, and we want to find its length. The hanging line will form an arc. Recall that arc length can be found using the integral of the square root of 1 plus the square root of f prime of x dx from a to b. We are given a function that we'll call f of x, and we first need to find f prime. Differentiating, we find that f prime is equal to the hyperbolic sine of x over 30. Now let's substitute this for f prime, as well as our limits of integration in the arc length equation. So we get the integral of the square root of 1 plus the square of the hyperbolic sine of x over 30 dx from negative 45 to 45. Recall that 1 plus the hyperbolic sine squared of x is equal to the hyperbolic cosine squared of x. So we can substitute the hyperbolic cosine of x over 30 for the square root of 1 plus the hyperbolic sine squared of x over 30. Finally, let's integrate. We have to use u substitution here, but it's a simple substitution, so we'll go right to the next step. We end up with 30 times the hyperbolic sine of x over 30 evaluated from negative 45 to 45. Substituting, we get 30 times the quantity of the hyperbolic sine of 3 over 2 minus the hyperbolic sine of negative 3 over 2. Remember that the hyperbolic sine of negative x is equal to the hyperbolic sine of x. So, we can rewrite this expression as 30 times the quantity of the hyperbolic sine of 3 over 2 plus the hyperbolic sine of 3 over 2. Simplifying, we get 60 times the hyperbolic sine of 3 over 2. Approximating, we find that this is approximately equal to 127.757. Therefore, the length of the power line between the 2 points is 127.757 feet.